the playground.
Oh, the deck of cards was the third one from the right, so the second one from the left. It was right there in front of you, Linda. That was the deck of cards pile. It was, originally, when I was standing up there. And maybe it changed. So, hello, hi. A lot of stuff to turn in, apparently. How many of you did all 3 quizzes this week? Yeah, a couple of you. Good, 3 or 4 of you. Good, good, good. You don't have to, obviously. You can do 1 or none and make them up later. How many did the deck of cards one? Oh, cool. And Excel behaved for you for good, good. We're gonna do more and more of that as we go through the term. That is the way you solve that problem. Did you notice that when you ran the Excel simulation how many did like 10,000 trials or something? Put the F9 button, go get a drink, come back. Did you notice that the number you got was very similar to the number we got in class by using a binomial distribution? Very close. Right, off by probably less than 0.5%, in most cases, maybe 0.5%, 0.75%. And the more trials you get, the better the estimate will get, obviously. How many trials did anybody go above 100,000 trials? Let the thing sit there like all night? No, not worth electric bulb, exactly. But the point is, and you started learning this in 243, we're not done with it in 244, it's not going to stop there. Sometimes problems can't be solved by hand. They must be solved that way. That's an example of one that can be solved both ways. And the whole point of doing it both ways was to have you guys compare the result you got with the computer to the result that you already knew was true based on the binomial distribution. But then apply that logic to something that you don't know the true answer to, and you can see the power. A mathematical problem that couldn't be solved 50 years ago is now within our grasp. Does that make sense? Maybe it doesn't yet. It's okay, it's 8:15. We'll come back to it. But that's the power of what's called a Monte Carlo simulation. Monte Carlo simulations allow you to solve mathematical problems that you can't solve otherwise. It's how tons of mathematics is done today in the world. I wish it was actually part of the curriculum. I'm forcing it to be part of the curriculum by sliding it in sideways next to things. I hope you don't get pissed off at that. But I want to keep doing that because it is an extraordinarily valuable tool. I found about 5 or 6 people around the country that are doing it too, and we all compare notes with each other, and we're eventually going to create like a consortium and then have textbooks and things like that, free open source stuff. That's what we have as we construct stuff. But it's just one of those things that is just now starting to crack the surface of academia. It's been used in industry for years and years and years. It's just now finally starting to trickle down through academia. So I'm going to try to keep paralleling what's in the true curriculum of this course with that stuff too, so you can see how they both play out. Make sense? Cool. And then the other 2 quizzes were just review quizzes. And there was a 4th quiz I sent you home with, which was the in-class quiz. I wanted to go through that today to make sure we understood how to do everything. That stuff was brand new as of Tuesday, I guess. So I wanted to make sure that we understood how to run everything. So if you turn it in, if you want to grab it, that's totally fine, and just make sure that we're all... Ron, what's up?
Do you have another copy?
Shoot. Maybe. Let me look. Crap, you must have left right before I handed it out, huh? Oh, wait, maybe. Hot damn, I do.
Awesome.
Yes.
3?
A few extra. 3, yes. Yeah, that's right. A little bit early. Here we go for you. You're more than welcome. Anybody else need what, 4? Do I hear 5? 6. No, I do hear 5. I just didn't hear it. See it. There we go. 6. Okay. Next, I'll leave them up here. And this is Joel. Joel, you here? I didn't see her. And I got blanks. All right. It's just blanks. I'm going to put this over here. So let's just make sure we know how to answer these questions, represent them pictorially, and I got a bunch of questions and emails about that MMD note on the quiz. I want to make sure I didn't define that in class. I mentioned it in passing once, I think, on Tuesday. And that's okay. That doesn't mean that you're expected to know what it is after hearing it one time. That's ridiculous to think that. So let's go back to it and make sure you understand why it's important, because it is hugely important. So we're going to use our TIs to crunch these intervals, for sure. You don't want, I mean, you could crunch it by hand. We did one in class on Tuesday by hand. But then, as I've often promised you guys, once you do it by hand, you know how it works. There's no reason to do it by hand again. Then we just focus on how to interpret the results, which is what the MMD is all about. Okay, cool. So let's